So here is a question from the May 2011 exam. It's from paper 2 and it's question 1. So we're given a triangle, as seen here, with 3 sides obviously. 2 of them have values of 7 and 9, and the third one is unknown. And we're given one angle, which is in between the 2 sides with the known values, and that's 120 degrees. So the first part of the question is to find angle, or not the angle, sorry, the side length of B, which is also AC. So there's 2 rules that will come into play throughout this question, and here the first one's going to be used, and that is the cosine rule, which is c squared equals a squared plus b squared minus 2ab cos c. So here we can adapt it to b squared equals a squared plus c squared minus 2ac cos b. When we add in the values of 7 and 9, we get b squared is equal to 9 squared plus 7 squared minus 2 times 9 times 7 times the cos of 120.
Stop hurting my brain.
B squared is then equal to 81 plus 49 minus 2 times 9 times 7 to the times negative 1/2, which is cos of 120. B squared, therefore, is equal to 130 minus 126 times minus 1/2, which works out to 130 plus 63, giving us the answer of 193, or rather the square root of that number. So B is the square root of 193. So that means part A is done. Then part B is finding the angle of A. So we'll mark that as theta. Here we're going to use the sine rule, as seen here, which is A over sine A is equal to B over sine B, which is equal to C over sine C. So here we have A, which is 9, over sine of A, which is unknown, equal to the square root of 193 over the sine of 120. So we cross multiply, and we get 9 sine 120 is equal to the square root of 193 times the sine of A. So then we remove the square root of 193 from the side with the sine of A by dividing both sides by the square root of 193. So then we get this. 9 sine 120 over the square root of 193 is equal to sine of A. So then we break out the calculator and you input this directly. So that sine A is equal to what's seen here. Here there's values I've put in which are rounded, hence the asterisks. It should be directly inputted into the calculator as seen here for the most accurate results. So having done that, we get sine A is equal to roughly 0.55. So then to find A, we enter that value as sine of negative 1 of 0.55 is equal to A, which gives us the value that A is about 33.86, so A is equal to 34 degrees. So we can cross this off, and theta is 34 degrees, and that's everything. So yeah, that is done.